I was trying to upgrade my system. I prepared a new DCF77 for receiver. I put it below my old one. I just want to look at the LEDs. You can see they blink up at the same time. Only this is set up more modular. This is my first experiment with the stereo FM receiver controlled by a microcontroller. I'm going to dismantle this whole project, but before doing so, for the last time, I will try to check if it still works. Switch it on. Yes, music is still coming out. I connected my amplifier to the internal speaker. Okay, that's it. Thanks for watching. So I rearranged my DCF receiver, on-off switch, connection to the power supply, and I put it on the board I stripped from the FM receiver. The loudspeaker has no function, it's just sitting there.
Left upper corner you see a number, but that is the number of the audio file that corresponds to this page. Here you can see my backups of my semi-RTOS basic program. It's just a bare program. No RTOS is used, but it uses many modules and each module has its own state machine. So I'll take me the last version. On the bottom is 2025-0517-1848, and it was derived from ZZIA from 2025-05031922, and that should be the number above it, so I can keep track of all my developments. First of all, this is a PowerPoint presentation. My goal is to transfer information, but I do not put any effort into making the layout neat, because that takes up unnecessary time. So here you see the contents of this zip file, which I unzipped in my new created development folder. The upper folder in this folder is an empty folder. It starts with 2025-0517-1848. This is the name of the zip file I backup this project. So inside the project I can see how it was backupped. There are some leftover files in this folder, like a hvw file, new text document, but it's not important. But let's go to the project file. Well, the third file from the bottom is the project file, the STW, ST Microelectronics Workbench or Workspace, I don't know. It's Workspace because I named it starting with WSP semi-RTOS base. I do not rename it, that's too much. It takes too much time. The file that you see now is the main.c. I always create a graphical picture of the microcontroller I use, so I do not have to open other documents if I want to know what pin 5, what pin port is used there. On the left side you see the Project Explorer. Under source files I create my own file, src source, and below that I create all typical modules and also the peripherals. Peripherals, that are the hardware items that are inside the microcontroller, like an I2C controller, the I/O ports and timers, hardware timers. Then you have the projects folder, hvw_macros. These are my own macros I created, hvw VW is my name, Henk van Winkoop. And below there are all kind of project defines. As you can see, there is also a module called FM_receiver. That was my last project. So in this project I will just remove this module, and all other modules I do not use, like the beeper.
So I downloaded my test program to see the onboard LED blink at a 1 second rate.
Well, here is a part of the main program. Main application has only a few states. There are 4 states shown here: standby, start, and highlighted start onboard LED timer and run onboard LED timer. So the function start state machine sets the state machine to the start state, and the start state goes to the start onboard LED timer. The start onboard LED timer initializes a software timer with a 1 second signal, and then it jumps to the machine state called run onboard LED timer. It checks if the software timer has expired and then toggles the onboard LED. The first thing I want to know if the signal that is coming from the receiver, DCF77 receiver, is the signal high enough to be able from the microcontroller to be detected as a high signal. So we now have to decide which pin we use for the DCF77 receiver. Well, in my main.c I choose for the pin PA1. It is used normally as a button press detection, but I now use it also for the DCF77 RX signal. So when looking at my oscilloscope on the output of the DCF77 receiver, the output level high is about 1.7 volt. According to the datasheet, it should at least be 2.3 volt. So then I removed the LED from the output, and then suddenly the output voltage is more than 3 volt. So now it should work.
First of all, I would apologize. I made some mistakes. I said it was 3,000 kilometers, as it is 2,000 kilometers, as it is stated here. And then this one also, I called it wrong. It stood here 120 milliseconds, it should be 200 milliseconds. Apologizing. With the help of a beer, I dismantled a previous project about the FM receiver, and I created me this one. The loudspeaker is not used, just there. Debugger programmer, STM8S103, an on-off switch is not needed anymore, and the DC77 is powered by, you can see it blinking each second, it's powered by a 3.3 volt from the programming interface. As you can see, I soldered the 10K resistor to enable the receiver on a pin header. I always do if I want to make it nice, and also the indication LED is on the pin header and in the plus signal of the LED I soldered it at 1 kilo ohm resistance, so to not yes. So there it is. My LED is blinking. The onboard LED is doing nothing. I look at my oscilloscope. You can see that the high level, is about 1.7 volts. That is too low for the microcontroller to detect a high voltage. So what I do then, I then just remove the LED. Okay. And then we see the high level is about 2.5 volt. I have seen it higher up, sometimes I do not understand, but it's more than a 2.3 volts, so it should work now. And as we look, you can see the onboard LED blinking. It just passed the 1 minute signal. Shorter and longer waves, it just decodes, but not very well. I don't know if you can see it on camera, but a 0 bit, a short one, is seen as a short blink from the LED. There's a 1 bit, which should be 200 milliseconds instead of 100 milliseconds. It looks very more bright. So maybe it is an optical illusion or has something to do with the human eye or the LED, but it's a thing I do not understand. Or it is some software problem. Many times on my oscilloscope I see a new bit receiving, but the onboard LED does not light up. The upper channel and the lower channel are both 2 volts per division. The upper channel is the incoming data. The lower channel is the onboard LED going on and off. So it doesn't make any sense what I see here. So I switched off the HMI state machine just for experiments, and what I see then is this. Input level and the onboard LED are very nicely synchronized, only the onboard LED, I switched it wrongly, the high-low level. I now know what is the problem in the HMI state machine. It checks if button 1 is pressed. That is just the PA1 input pin, which is coming from the DCF77 receiver, so it conflicts with each other. That the onboard LED shows an inverted signal is because when the onboard LED is powered on by port pin PB5, there's a transistor, so make it high on the base, then the collector will go low to start the LED to light up, and that's the signal we see on the collector. That's why it is inverted. So this is my main.c file. I always draw the outlines of the microcontroller I use, so it's nice to have a good reference. And then it is my program. The only thing it does is syscontrol init, syscontrol start, and continuously syscontrol run. And what the fuck is syscontrol? You will find it out. Syscontrol, all modules, even syscontrol, do have the same system if they use a state machine. Almost all modules do. There's an init function with the state machine, there's a start function, and there's a run, and eventually there's a connect function using callback functions. Here's the state machine run. It does only a few steps. First, initialize all modules. It calls the function that initialize all modules. It then calls the function that connects all modules by callback if needed, start all modules, and then finally run all modules. Here are the functions that are called. Init modules, it initialize all init functions of all modules. It then starts all functions of all modules, run all modules, and connect modules. This is the overall principle that is used in every other modules, having an init, a start, and a run function. So I inserted a DCF77 decoder module. Well, it has the same structure, and in it the start and the run function. And in the run function, it's here, I said just do something. You have to take a prototype, call it here because it's not defined, it's defined in the lower part of the file. Do something. The only thing it does, check if the DCF input is high, then set the onboard LED on, else set onboard LED off. That's all there is. It's not a good example because I should have placed this example in the application module. Application module is the overall boss seen from software over everything. So I should not make these test programs inside the DCF controller. I should put this experiment in the main application. But for now, it works.